Hello everyone, welcome back. So in this video we are going to learn about electrostatics and one of the basic law of electrostatics, that is Coulomb's law. If you are first time to my channel, please consider subscribing. Electrostatics. So the name only suggests it is due to electric charges. Electro stands for electric, charges, static means rest. Okay, so the name suggests that electro means is due to electric charges and static means rest. That is, electro or electric fields are due to charges at rest. Okay, charges at rest. So these charges at rest are also called as static charges. These charges at rest are also called as static charge. Okay, so that is, in electric field, the basic element, so in the electric field the basic element is charge. So basic element is charge, that is, the electric field is due to charges. So this charge is again classified into two types. One is point charge and the second type is distribution of charge. Distribution of charge. So point charge is somewhat like this. So a single point will be there and electric field will be produced along the charge. And similarly, distribution of charge is again classified into three types. One is line charge. That means distribution is along the line. So along a line there is distribution of charges. So the line charge density is given by rho L, that is total charge density is given by rho L, in which is represented in Coulomb per meter. Similarly, surface charge, whose charge density is given by rho S, represented in Coulomb per meter square. Similarly, volume charge, and its volume charge density is given by rho V, represented in Coulomb per meter cube. So these are the three types of distribution of charges. Okay, so if the line charge density is rho L, then the total charge is given by, so integral of L rho L dl bar. If the surface charge density is rho S, then the total charge is given by integral S rho S ds bar. If the volume charge density is rho V, then the total charge Q is given by integral V rho V dV. Okay, so these are the formulas of the total charge in terms of rho L, that is line charge density, rho S surface charge density, and rho V volume charge density. So next is, there are two basic laws of electrostatics. So two basic laws of electrostatics are, one is Coulomb's law and second is Gauss law. Coulomb's law and Gauss law. Now in this video we are going to learn one of the basic law of electrostatics, that is Coulomb's law. Okay, so next we'll discuss about Coulomb's law. So Coulomb's law states that the force F bar between 2 point charges, so the force of charge F bar between 2 point charges Q1 and Q2 is along the line joining Q1 and Q2, that is the force lies along the line joining the 2 point charges Q1 and Q2, and the force is inversely proportional to the square of the distance between them, and it is directly proportional to the product of charges Q1 and Q2. Okay, so this is the statement of Coulomb's law. So it states that the force F between 2 point charges, suppose there are 2 point charges Q1 and Q2 like this, so Q1 and Q2 like this, then the force is along the line joining, so the line joining Q1 and Q2 is this, then the force is in this direction. Okay, so the force is in this direction, that is the line joining this, and inversely proportional to the square of the distance between them. Suppose this is R, the distance is R from Q1 to Q2, so it is inversely proportional to R, that is the force is inversely proportional to square of the distance, that is R square, and it is directly proportional to the product of the charges Q1 and Q2, that is F bar is directly proportional to Q1 and Q2. So combining these two statements we can write as, so F bar is proportional to Q1 Q2 by R square. Okay, so combining these two, because force is directly proportional to Q and Q2 and inversely proportional to R square, combining those two statements we can write force is proportional to Q1 Q2 by R square. Suppose if you eliminate this proportionality constant, we can write F bar is equal to K into Q1 Q2 by R square, where K is some proportionality constant. So K is proportionality constant, which is given by 1 by 4 pi epsilon naught. So K is given by 1 by 4 pi epsilon naught. Therefore, combining those, we can write F bar is equal to Q1 Q2 by 4 pi epsilon naught R square. So F bar is equal to, and F into AR cap, since force is a vector quantity, so it also depends on vector, so AR cap is the unit vector along the direction R. Okay, so force in newtons. So this is the formula for force for electric fields for any 2 point charges Q1 and Q2. This epsilon naught is called permittivity of free space. Permittivity of free space, which is given by the, which is represented in farad per meter, and its value is given by epsilon naught is equal to 8.854 into 10 to the power of minus 12 farad per meter. So what is this epsilon naught? Epsilon naught defines the ability of free space, ability of the free space to store the electric charge, Okay, so that is why it is called as permittivity. So ability of the free space to store the electric charge is represented by epsilon naught, which is called as permittivity of free space, and its value is given by 8.854 into 10 to the power of minus 12 farad per meter. So 1 by 4 pi epsilon naught is given by 9 into 10 to the power of 9 meter per farad. Okay, so combining these, what can we write is, so if you have 2 point charges, so suppose this is origin and there is Q1 here and there is Q2 here, Q1 here and Q2 here. So if there is a line joining Q1 and Q2, so this is the direction of force exerted by Q1 on Q2, that is, this is the direction of F12 bar, and this is the direction of force which is exerted from Q2 to Q1, so this is F21 bar. Okay, so if the direction of Q1 and Q2 is F12 and direction of the force of Q2 on Q1 is F21. Suppose the distance is R1 here and the distance from origin to point Q2 is R2, then the distance between Q1 and Q2 is given by R, the capital R. Then F12 bar is equal to Q1 Q2 by 4 pi epsilon naught R square AR12 cap. Okay, so this is the basic formula of Coulomb's law. The force exerted by force exerted between 2 point charges Q1 and Q2. So what is R12? R12 is equal to R2 minus R1. Okay, so if you take the unit vector AR12, then it is R2 minus R1 by modulus of R2 minus R1. So all these are vectors. R2 bar minus R1 bar. Okay, so similarly the direction, since we can see here the directions of F12 and F21 are opposite, so F12 direction and F21 directions are opposite to each other, but they are equal in magnitude. So they are equal in magnitude but opposite in direction, so we can write it as F12 bar is equal to minus F21 bar. Okay, so F12 bar is equal to minus F21 bar. Also, if there are many point charges from origin, suppose there is a point charge Q which is at the distance of R from origin, and there is point Q1 which is at a distance R1, and similarly there is another point charge Q2 at a distance of R2 and Q3 at a distance of R3, so on. So there is a point charge Qn at a distance of Rn. Then the force, the total force exerted by the charges Q1, Q2, Q3 and so on up to Qn on Q, or the force exerted by Q on Q1, Q2, Q3 and so on up to Qn obeys superposition principle. Superposition principle, that is, the total force is equal to the individual forces exerted by each and every individual charge. That is, the charge force of attraction between Q and Q1, if you take it as Q1, so the force exerted by that F bar plus Q, so total force F bar is equal to the force due to Q on Q1 plus the force due to Q on Q2 plus the force due to Q on Q3 plus so on, plus the force due to Q on Qn. That is, it obeys superposition principle, which is given by the formula, so Q by 4 pi epsilon naught summation k is equal to 1 to n Qk into R minus Rk divided by mod R minus Rk whole Q. So this is the total formula, or this is the total force exerted by the Q on different charges, that is from Q1, Q2, Q3 and so on up to Qn.